All right, so today we're going to use some of the stuff we talked about in the last unit with all of our graphs to look at some real world scenarios. And I have my Desmos window open because Desmos makes this a lot easier. So this situation is a small rocket has been launched into the air. The path of the rocket is given by this equation. So this models the path of the rocket, and then here we have the picture. So how long is the rocket in the air? We start. This shows that the graph was launched from the ground. It goes upward. Here, if you recognize, this is the vertex, and then that's the turning point. So it turns and it goes back down toward the ground. And this is when it hit the ground. So how long was it in the air? It was in the air for 8 seconds. What's the greatest height the rocket reaches? So, as we said, it starts on the ground and it goes up to here. Once it gets here, it turns and it goes back down to the ground. So this is the height. Remember, this is our maximum point of our graph. So when we're talking about the height, this, the x-coordinate, is the time. So when did it reach its maximum height? At 4 seconds. The question was, what is the greatest height? So we have to follow this over to the y value, which represents our height. So, and this is counting by 10, so 260 feet would be the greatest height that it reached. About how high is the rocket after 1 second? So if we follow the 1 up, I'm going to say it's right there in the middle. So I would say 105 feet. After 2 seconds, I will follow this x value, and they have a little point right here. So that's 190 feet. And then it asks, is the rocket going up or down? So remember, it starts here and it's going upward. So after 6 seconds, about how high is the rocket? So if I follow the 6, I'll see it's right here also at 190 feet. Now on this side, is the rocket going up or down? This is after its turn and it's going back down. Number 6 asks, do you think the rocket is traveling faster from 0 to 1 second or 3 to 4 seconds? So if we look from 0 to 1, what is the difference? Starts at the ground. So that is 105 feet that it traveled, right? From 3 to 4, here's 3 to 4. So 3, okay, so here is 3 to 4. If that's 240 feet, 240 to 260, that's going to be 20 feet. So it traveled 20 feet in 1 second here and 105 feet in 1 second there. So was it traveling faster from 0 to 1 second or 3 to 4? The rocket was traveling faster from 0 to 1 second because it traveled 105 feet. Now it says using the equation, find the exact value. We are doing that later. So we're going to go on over here to what's the domain and range. So it started at time 0 and it ended at time 8. So the domain is from 0 to 8. Again, this one won't be all real numbers because we don't have negative time. And the rocket does not keep going after 8 seconds. It burns out on the ground. And then the range is from 0 at the ground all the way up to 260 feet. It does not go past that, and it doesn't go through the ground. So from 0 to 260 feet. So what interval is the graph increasing? What is it decreasing? So we are writing our domain and range in interval notation. So you already know interval notation. So from 0 to, what was that, 4, it was increasing. And then it was decreasing the rest of the way from 4 to 8. All right. So a ball is thrown into the air is this story. When is the ball at its maximum height? Right here. And I already printed this one. This is from Desmos. And I went ahead and I labeled the vertex for 16. So when is the ball at its maximum height? The when is 4 seconds. And what is the maximum height? Would be up here at 16 feet. It actually does not tell us if it's seconds or feet, so I'm kind of making that up. And then when does the ball reach the ground? So it hits the ground. Look at that. It's the same right here. 8 seconds. Okay. A swim team member performs a dive from a 14-foot high springboard. So you notice the y-intercept is at 14 because that's where the diver or swimmer is starting from. Then it asks, what is the maximum height the ball reaches? So that's right here. Looks like it's counting by 22 or 2, so that's 22, and it's in between 22 and 23. So let's say 23 feet because it says height in feet. And then how far away is the diver from the springboard when they are in their maximum height? So the distance from the springboard, this is not time this time, distance from the springboard. So we're looking at the X value for this question. How far away when he's at his maximum? Well, that answer would be 3 feet. And then when did the diver hit the water? Oh my goodness, it's 8 again. Is that, oh, actually that's a terrible question. Terrible question. We have to mark that off because this is feet, not time. Okay. Here's another quick one. This is another rocket launched from a hill 80 feet above the lake. Notice it's 80 feet above the ground. The rocket will fall into the lake after exploding at its maximum height, which would be here at the vertex. So what is the maximum height the fireworks reached? The maximum height is 144 feet. We know that because it's using feet. When do the fireworks reach their maximum height? Well, that would be our X value here at 2 seconds. I'm going to say seconds because it doesn't say in the problem. What does the y-intercept mean? Well, we just talked about that. The y-intercept means that the rocket started 80 feet off the ground. Okay, after t seconds, a ball is tossed in the air. We do not have a graph for this one because I wanted you to use Desmos. If you would like to pause the video, you can, and then you can pull up Desmos and you can type this in yourself. So h of t equals 144 t minus 16t squared. And if you'll notice now, my graph is a little weird. It's a little funky. So I can go to this wrench and I can change it up a bit. I have plenty of space width-wise of the domain, but I need to go up higher. So I'm going to click on my wrench and I'm going to look at the y-axis. So right now the y-axis almost goes up to 20, and that's not enough. I'm going to try 50. And then X out of here. Was 50 enough? Not even close. So what do you want to try next? Let's try 100. Oh my goodness, we still got to keep going. So I'm going to try 200. Let's try 300. Almost. Let's do 350. What happened? Oh, I did. Okay, sorry. 350. Okay, much better. Okay, so now I can look at this graph. I can see the whole thing, and I can see where it starts. I can see the top of the graph, and I can see where it ends. So where it says, what is the maximum height the ball reaches? Well, that would be our vertex here, yes. So what does that say? The maximum height is 324 feet. Yeah, this time it says feet in seconds. When is the ball at its maximum height? Well, that's 4.5 seconds. And when will the ball reach the ground? Well, it reached the ground at 9 seconds. So you can see how nice and easy Desmos makes this.